This presentation is from the Properties of Matter unit in the National 5 Physics course and will be mainly about specific latent heat. Don't be put off by the number of slides, as there is a lot of revision from S1 included in this presentation. Think back to S1 science, or if you're doing chemistry, what do you know about the states of matter? Keep these thoughts in your head as you flick through the next few slides. This should represent your knowledge of solids, liquids and gases from S1. Read it carefully before you move on. You might want to pause it to refresh your memory, especially if you're not doing chemistry. Here is some extra information about solids. Again, this really should be revision. You might want to pause the slide and read it before moving on if you can't remember your S1 science knowledge on solids. Here is your liquids knowledge from S1. Again, it might be worthwhile pausing the slide and reading through it carefully to refresh your memory about what you know about liquids from S1. In particular, you might want to look at the Y column on this slide. Your final revision slide on states of matter is all about gases. Again, read through the slide carefully, pause it if you need to, but this should not represent new knowledge. This is what you should know before you started your N5 physics course. Again, you might want to pause the slide to read through it carefully. Again, this question is from S1 Science. You will have done changes of state lower down the school. Again, think carefully about changes of state. When we add heat energy to a state of matter, we can maybe make a solid become a liquid or a liquid become a gas. You might remember from S1 that solids becoming liquids is called melting, and liquids becoming gases is when boiling takes place. If you take heat energy away from a liquid or a gas, we can change their state as well. Removing heat from a gas is called condensing and produces a liquid. Removing heat from a liquid is known as freezing and will produce a solid. Again, this should have been covered in your S1 science course. You've probably never thought about this before, but that top line, when a change of state takes place, there is no change in temperature, is a key concept in specific latent heat. Water freezes at 0 degrees and only at 0 degrees C. Water boils at 100 degrees C and only at 100 degrees C. When a change of state takes place, it happens at a fixed temperature. There is no change in temperature when a change of state is taking place. The next slide will show you a graph which represents this. You should spot that there are only two shapes in the graph, flat and a slope. When the graph is flat, that tells you that a change of state is taking place. When there is a slope, that represents a change in temperature. Look at the graph closely, you'll see that sections B and D represent changes of state, and sections A, C and E represent changes in temperature. In N5 physics, the changes involved in liquids and gases are known as vaporization changes. You are used to calling them boiling and condensing, but in your exam questions it will talk about vaporization changes. Remember, vaporization is when liquids and gases are changing state. Similarly, when solids and liquids are changing state, you would normally say we're talking about melting or freezing. For N5 physics, when a change of state involves a solid or a liquid, we say that there is a fusion change taking place. This diagram hopefully illustrates the last two slides. Vaporization and fusion can be summarized in the diagram. The red arrows at the top are trying to indicate heat being added, and the blue arrows at the bottom are trying to represent energy or heat being removed. Here we have the equation for specific latent heat. You will see that it's a three-variable equation. EH equals m times L. Heat energy equals mass times specific latent heat. As it's a three-variable equation, you will be able to make it into a triangle. If you look at the triangle, covering E leaves you with m times L. When you cover m, you're left with E divided by L, and if you cover L, you're left with E divided by m. This simple set of apparatus will allow you to calculate the latent heat of water. For vaporization, here are the steps that you would carry out using this simple apparatus. Take a note of the kettle's power rating. Boil off a known mass of steam, measured on the scales in kilograms. Use the stop clock to time the boiling process. Calculate energy E from E equals P times T. You can now calculate the latent heat of vaporization of water by using L equals E divided by M. You might want to replay this bit of the slideshow again, to familiarise yourself with this experiment. It is a very common experiment in past paper examples. This table can be found on the datasheet when you do assessments. It might be worthwhile learning the vaporization value for water. 22.6 times 10 to the 5 joules per kilogram. This is not the same data table. If you look at the top, it's all about fusion. Again, you would find this on the datasheet when you do an assessment. And again, it might be worthwhile learning the fusion value for water as 3.34 times 10 to the 5 joules per kilogram. Reading the question carefully, you seem to have only one piece of data. Look at the hint on the solution. If you've only got one bit of data, you then go to the data sheet to help you do the calculation. It's melting. For N5 physics, melting is a fusion change. So you would look up the fusion data table. When you've looked up the data table, it's a straightforward substitution and you should get the answer correct. Again, there's only one bit of data in the question, but remember a data sheet can help you. This time we're doing a vaporization change. Water is becoming steam, so we're boiling. Boiling is a vaporization change. Look up the vaporization table. If you look up the vaporization table for water, the calculation should become straightforward. For this one, a graph is used. Remember, horizontal lines in a graph represent changes of state. Slopes represent changes of temperature. So Q to R is horizontal. It's a change of state. That's the solid to liquid change. S to T is a horizontal line. That will represent a change of state. In this case, liquid to gas. Be careful this time because you have to calculate the energy by using time in seconds. You'll also see it's a part A. This example is actually an exam standard example because it has more than one part to it. Changing the time into seconds hopefully makes the calculation for A straightforward. So part B allows you to use your properties of matter knowledge. EH equals M times L. Remember to look up the correct table when you're doing this. It's boiling. Boiling is a vaporization change. By looking up the vaporization table, you should get 11.2 times 10 to the 5 for the L value for alcohol. Filling the values in, you should get a straightforward calculation to get the M number. There is no need to copy the table, but you should attempt all 6 calculations. Might be worthwhile pausing the slide before you move on to the next slide, which has the answers. Here are your 6 answers. How did you do? Pause the slide, check how you did before you move on to the next slide. If you need any help, just get in touch. These final 4 questions will review your knowledge on specific latent heat. It might be worthwhile pausing the slide, trying all 4 before you review the answers. Remember, data sheets might be useful for helping you get the answers. Again, you might want to pause the slide here, take a note of the data before moving on. Question 1 is a straightforward knowledge question. You should know this as a fact already. Question 2 requires you to look up a fusion table and be able to use EH equals M times L. Hopefully you looked up the correct table and you've got the correct answer. Question 3 needs you to look up a vaporization table. When you've got the L number, it's a straightforward EH equals ML calculation. Question 4 was actually taken from a past paper. Well done if you've got this right. To solve it, you need to identify that the solid to liquid change is happening between 2 minutes and 6 minutes. You should then be able to calculate energy from E equals P times T. Remember, T needs to be in seconds, not minutes. Once you know the E number, you can use M equals E divided by L to get your answer. Remember, you can look up the latent heat of fusion of lead on a data table. How did you do? If you need any help, just get in touch.